Introducing Psi-Zero, an open foundation model towards universal humanoid loco-manipulation. Built to understand, move, and interact in the real world, Psi-Zero brings together whole-body control, dexterous manipulation, and long-horizon task execution. From mobile alignment to contact-rich interaction, from bimanual coordination to continuous control, it's designed to operate across space, contact, and time. Across reaching, carrying, wiping, pushing, and repositioning, Psi-Zero composes diverse motor skills into coherent, long-horizon behavior. Rather than solving isolated actions in isolation, it coordinates perception, embodiment, and control across extended sequences of interaction. These behaviors demand not only dexterous hands, but also stable locomotion, continuous scene understanding, and smooth whole-body execution in real-world environments. Each task is more than a single manipulation primitive. It is a sequence of embodied decisions aligning to the scene, maintaining stability, interacting through contact, and transitioning fluidly from one sub-goal to the next. This is where humanoid intelligence begins to matter, not in isolated motions, but in sustained behavior that unfolds continuously over time. Such capability comes from learning at scale from human experience. Unlike approaches that rely on generic internet data, we focus on high-quality, egocentric human data, which can be collected from everyday activities across the world. This gives Psi-Zero rich semantics and behavioral priors, which we combine with real humanoid robot data to bridge the gap to embodied perception and control. Together, this forms the foundation of Psi-Zero. To achieve superhuman-level intelligence, Psi-Zero is designed as a triple system architecture. System 2 is a vision-language backbone that interprets the instruction, understands the scene, and produces high-level intent. System 1 is a flow-based MMDT action expert that predicts future whole-body action chunks. System 0 is an RL-based tracking policy that converts those actions into stable, executable joint commands. Together, these three systems separate reasoning, action generation, and control, forming a more scalable and effective architecture for humanoid loco-manipulation. To effectively train this system, Psi-Zero follows a three-stage learning pipeline. First, we pre-train the vision-language backbone on large-scale egocentric human video, enabling the model to learn task semantics, rich visual representations, and human behavioral priors. Next, we freeze the backbone and train the action expert on cross-task real humanoid data, grounding those representations in embodied whole-body control. Finally, we fine-tune the model using a small amount of in-domain teleoperation data, enabling rapid adaptation to long-horizon tasks. Together, this training recipe tells a clear story. Scaling the right data at the right stage is the key to building capable humanoid intelligence. Deploying Psi-Zero requires more than simply running inference on a large VLA model. With over 2.5 billion parameters, a naive rollout introduces significant latency and a stop-and-think behavior that is unacceptable for reactive humanoid control. To address this, we built a synchronized real-time deployment stack between the robot and the server from the ground up. On the server, VLA inference runs on an NVIDIA 5090 GPU within a tightly synchronized control loop and inference loop. The control loop maintains the currently committed action chunk and the robot's state. Meanwhile, the inference loop predicts the next chunk conditioned on the actions already being executed. This is the key idea behind real-time chunking, or RTC. With this customized deployment pipeline, Psi-Zero produces smooth, stable, efficient, and human-like behavior in the real world.